A sequence t1, t2, tn is defined as follows. T1 is equal to 14, tk is equal to 24 minus 5, tk minus 1 for k greater than or equal to 2. For every positive integer n, tn can be expressed as tn equals p times q to the n plus r, where p, q, and r are constants. The value of p plus q plus r is. Alright, so first let's try to understand this question. They're saying that t to the n is equal to p times q to the power of n plus r. Okay, that's our big relationship right there. And then they tell us that t to the n is equal to 24 minus 5t to the n minus 1. Well, they're using k's, but just keep it consistent. N, k, same thing. So let's first look at this one here. If t is 1, we'd have p times q to the power of 1 plus r. If t is 2, we'd have p times q to the power of 2 plus r. If n is 3, t3, we'd have p times q to the power of 3 plus r. So you get the point, right? t1, t2, t3, you just plug in 1, 2, and 3 where the n is right here. Now let's turn our attention to this guy right here, t to the n. T to the 1 they've given us as 14. That's given right here. So we'll figure out t2, t3. And let's see what we get. So t2 is going to be 24 minus 5 times t1, like that. So 24 minus 5 times 14, and therefore this is 24 minus 70, which is equal to minus 46. All right, that's t2. Now let's figure out t3. So t3 is going to be 24 minus 5 times t2. So 24 minus 5 times t2 is minus 46, and therefore 24 minus 5 times 46 is what, 230? Yeah, about approximately 230 plus 230. So this looks like 254 for T3. Okay? So far, I hope there's no confusion here. I just figured out T1, 2, and 3. Okay, so the good news is we've got some integer values for T1. Where's T2? T2 is right here. It was negative 46. And T3 is 254. Okay? And we know that T1 on this side is equal to PQ plus R. T2 is PQR squared. And T3 is PQ to the third plus R. Like that. And I think at this point you kind of know what's going to happen. We're going to set these equal to each other, like that. And we will try to solve for P, Q, and R. And I think we can because we have 3 equations, 3 variables, and that is usually the recipe. So let's go with T1. We got T1 is 14, and that is equal to P times Q plus R. The next one is T2, which is minus 46, is equal to P times Q squared plus R. And finally, we have 254 is equal to P times Q to the power 3 plus R. All right, not as straightforward as you know, normally, you know, they just have X, Y's and all that stuff. We got some exponents in there, but that's okay. We can still do this with a little bit of fancy manipulation. So I'll call this 1, I'll call this 2, and I'll call this one 3, the equations. So the first thing I saw is that I can probably get rid of these R's pretty quickly. Anyway, like 2 minus 1, that would get rid of the R's. So if I did 2 minus 1, I'd have minus 46 minus 14. And on the other side, I'd have pq squared plus r minus pq minus r. So this becomes minus 60. And this becomes pq squared minus pq. And the r's do indeed disappear. So that's good. And this becomes minus 60. If you factor out a pq, this will give you just q minus 1, like that. And I think that's about as far as we can go there. And we can do something very similar with 3 and 2, 3 minus 2. That would be beneficial. So we have 254 minus 46, and that would be pq to the power of 3 plus r minus pq squared minus r, like that. So this becomes 300, and the r's cancel, so that would be pq to the power of 3 minus pq squared. And in a very similar way, factor out pq squared, and this would be q minus 1. Okay? So these two now, we can use this equation and this equation to solve for at least one of these variables. And I look at them and they look very familiar, or very similar, I should say. Not familiar. I haven't seen them in the past. But if I divide one by one, I think I should be able to isolate a variable. So if I make the numerator this guy right here, so on both sides, and then divide by this equation, you will see that you can isolate for one variable. So the left side just becomes -5, but watch, this cancels, that cancels, the p's cancel, and you're just left with q. So there you go. We've got q is equal to -5. So that's good. Now we can solve for p. We can just put it back into here, or anywhere really. So if I put q equals -5 into there, let's see what I will get. Minus 60 is equal to minus 5p minus 5 minus 1. So minus 60 is equal to minus 5p times minus 6. So that's 30p is equal to minus 60. And therefore p is equal to -2. Great. And then I think I have just one variable remaining, right? R. So I can use any of these equations that I got up here. This one seems simple enough. 14 is equal to pq plus r. All right, let's use that one. So 14 is equal to p times q plus r. So 14 is equal to minus 2 times minus 5 plus r. 14 is equal to 10 plus r, and therefore r is equal to 4. And there you have it. And they wanted us to figure out what is value of p plus q plus r. P plus q plus r, all right? So p is -2, q is -5, and r is 4. This is p plus q plus r. And therefore that looks like minus 7 plus 4, which is minus 3. So minus 3 is our answer. Let's see if that's one of the answer choices. And it is choice B.